Welcome to the Deep Dive. We're here to unpack complex ideas, get right to the heart of things for you.
That's the goal.
And today, we're plunging into something fascinating but often, totally invisible. Network address translation, NAT.
Right. NAT. It's like the internet's silent organizer working away behind the scenes.
It really is. And it underpins so much of what we do online every day, doesn't it? Streaming movies at home, big companies running their data centers.
Absolutely. It might sound technical, maybe a bit dry even, but its role is incredibly fundamental.
And it actually came about because of a looming crisis, right?
Yeah.
The big problem NAT was invented to solve. It looks like planning this huge barbecue for, say, 4 billion people.
Uh-huh.
But then you realize you've only got, 3 sausages. Or maybe just a few million plates.
Yeah, that's a good way to put it. We were running out of IPv4 addresses. Still are, technically.
Okay. So NAT was this clever way to basically stretch those limited addresses,
Right.
make them serve countless devices. So our mission today, make this whole NAT thing crystal clear.
Yep. Using analogies you won't forget, hopefully.
Let's start with the basics. How should we picture NAT working, say, on a home network?
Okay, well, think of NAT as a very specific kind of party bouncer for your house network.
A bouncer.
Yeah. Inside your house, you've got all your devices, laptop, smart TV, phone, whatever. They're all using what we call private IPs.
Right, the 192.168 stuff.
Exactly. You can think of those devices as wearing their comfy pajamas. Unique inside the house, totally fine there, but not really suitable for the outside world. The internet can't see them directly.
Okay, so pajamas inside. Got it. But what happens when, my laptop wants to check the news or the TV wants to stream something? They need to go out onto the internet.
Right, and they can't go out in their pajamas. That's where the NAT bouncer steps in.
Uh-huh.
NAT makes sure that when any of those devices send traffic out to the internet, they all appear to be coming from one single address, your public IP.
The one my internet service provider gives me.
Precisely. So from the internet's perspective, it just sees one VIP leaving your house, not a whole crowd in pajamas.
So it's like everyone puts on the same fancy tuxedo at the door. Or remember that Russell Crowe movie, Master and Commander?
Oh, yeah. Great film.
It's like that one big ship, the public IP, hiding this whole fleet of smaller boats.
Yeah.
All my devices behind it.
It's a brilliant analogy, actually. It is a kind of clever deception, hides the complexity inside.
And that's how, millions, billions of devices can share a much smaller pool of public internet addresses.
It really is. But that brings up the obvious next question, doesn't it?
Right. If everything going out looks like it's coming from that one address, that one VIP,
Right.
how does the stuff coming back know where to go?
Exactly. How does Netflix send Bridgerton to your specific TV and not, your mom's iPad, which might be on the same network? They're both behind that same public IP.
Yeah, this seems like a huge problem. If they all look the same from the outside, how does anything get back to the right place inside? Is there some, super complicated lookup table?
Well, it is a lookup table, but the magic ingredient is something called ports.
Ports, okay.
Think of ports as tiny, unique seat numbers attached to every chunk of data, every packet.
Seat numbers.
Yeah. They're numbers technically from 0 up to 65535. They tell your device which specific application or service that data is for. So port 80 is usually for web browsing, 443 for secure web browsing, others for email, games, streaming.
Ah, okay. So the data knows which door to knock on once it gets back to the house, but how does NAT know which device that door belongs to?
Right. NAT uses what you could call its cheat sheet. Technically, it's the NAT translation table. It keeps track of everything.
A cheat sheet. I like it.
Yeah.
So let's walk through that. My laptop, let's say it's 192.168.1.15 inside my house, wants to talk to Netflix. It sends out a request from a specific port number, right? Say 54321.
Exactly. That's step one. Your laptop sends a request. Hey, Netflix, I'm 192.168.1.15 using port 54321. Send me the stream.
Okay, then what?
Step two. NAT, sitting on your router probably, intercepts that request just as it's leaving the house. It rewrites the from address.
The tuxedo moment.
Kind of. It swaps out your laptop's private IP, 192.168.1.15, and its port, 54321, with your public IP address, say, 203.114.13.8, and it picks a new, unique, outgoing port number just for this conversation. Let's call it 42100.
So the request reaching Netflix now says it's from 203.113 on port 42100.
Precisely. And NAT jots this down on its cheat sheet. Traffic coming back to public port 42100 belongs to internal device, 192.168.115 on its port by 4321.
Okay, step 3. Netflix gets the request and sends the data back to
Yeah.
the public IP in that special port 4100.
Correct. Netflix has no idea about your laptop's private IP or its pajamas. It just sends the stream back to the address it sought. 203.0.113.8.42100 knows instantly that this data is meant for your laptop at 192.168.145, port 54321. It rewrites the destination address back to the private IP import.
And boom, Bridgerton appears on my laptop screen, not Mom's iPad.
Exactly. It's like the world's busiest, most efficient matron, keeping track of hundreds, maybe thousands of conversations, making sure every piece of data gets delivered to the right table, the right device.
That's a fantastic analogy, the maitre d' of the home network. No mix-ups allowed.
No mix-ups allowed. Get it
Okay.
wrong, and you've got digital chaos. Or maybe your mom gets your video game traffic, which could be weird.
Definitely weird. Okay, so that's the core idea. But you mentioned it's not one size fits all. There are different flavors of NAT.
That's right. Different types for different situations. The main ones you'll hear about are SNAT, DNAT, and PAT.
Okay, let's break those down. SNAT first, source NAT.
Mhm.
Is that the everyone puts on the same trench coat analogy we touched on earlier?
That's a great way to think about it, yes. SNAT is primarily used when devices inside your network need to initiate a connection out to the internet.
Okay.
It changes the source address, the from address from the private IP to the public IP. So yeah, everyone leaving the party puts on that same coat.
Makes sense. So what about DNAT? Destination NAT. You said something about a pizza guy.
Right. DNAT is kind of the reverse. It's for handling incoming connections from the internet to a specific device inside your network.
Ah, so like if I'm running a game server at home and my friends need to connect to it from outside.
Exactly that.
Mhm.
Or maybe accessing security cameras remotely, or a home web server. DNAT takes an incoming request aimed at your public IP on a specific port.
Like the pizza guy arriving at the main entrance.
And the DNAT rule, like a bouncer with instructions, ushers that request, or the pizza guy, directly to the correct internal device, the kitchen or your game server. It changes the destination address. That's why it's often called port forwarding.
Port forwarding. Okay, heard that term. So SNAT for going out, DNAT for coming into specific services. What's the last one? PAT.
PAT, port address translation. This is actually one most of us use every single day without realizing it.
Oh, how so?
Well, PAT is what allows many, many internal devices to share usually just one single public IP address. It's a specific type of SNAT, really, but it heavily relies on those port numbers we talked about.
So this is everyone wears the same trench coat, but carries a unique colored coffee mug idea.
Perfect analogy again. The trench coat is the shared public IP, and the unique coffee mug is the unique source port number NAT assigns to each outgoing connection.
Ah, so it's not just changing the IP, it's using those thousands of available port numbers to keep track of potentially thousands of simultaneous conversations from different devices, all sharing that one public IP.
Precisely. That's the real workhorse. Most home routers, most corporate firewalls, they're doing PAT. It's incredibly efficient. And you could argue PAT is one of the key things that allowed the internet to scale the way it did. Without it, we'd have run out of IPv4 addresses much, much faster, or getting online would have been way more expensive.
Wow, so PAT basically subsidized the growth of the web and like all these smart devices we have now?
In a very real sense, yes. It kicked the can down the road on IPv4 exhaustion, maybe longer than anyone expected.
Okay, let's try that Uber analogy to tie these together. SNAT is me calling an Uber from inside my house. My location is hidden initially.
Right. DNAT is the Uber driver being given specific instructions to navigate a confusing apartment complex to find me at a specific apartment door.
Okay, and PAT is everyone in the building sharing one single Uber corporate account.
But each person gets a unique seat number when they ride, so the driver knows exactly who's who and where they're going, even though it's all billed to the same account.
That works. That really clarifies the differences.
Good. And just very briefly, you might sometimes hear about NAT-64 or NT66.
Okay.
Those are more advanced types, mainly dealing with the transition and interaction between the old IPv4 networks and the newer IPv6 networks. Important for the future, but the core ideas of SNAT, DNAT, PAT are the bedrock.
Got it. So this all sounds incredibly clever and, frankly, essential. But sometimes the best way to appreciate something is to see what happens when it goes wrong or when it saves the day.
Yeah.
Do you have a real-world example? Maybe something dramatic?
I do, actually. Picture this. Black Friday, busiest shopping day of the year, flagship retail store, huge crowds.
Oh, boy. High stakes.
Extremely high. And suddenly, their main fiber internet connection just dies. gone.
Nightmare scenario.
Total nightmare. They had a backup plan, though, an LTE connection, like from a mobile network.
Okay, good. Backups